just wanted to make a quick video for you in case you were absent, in case you missed some details, or in case there's something that you just need to go back over again, okay? All right, so listen, you don't need to see Screencast-O-Matic. That's a little weird, but that's what I'm recording this on. Okay, so here is our home screen. So if you need to know where to go to find things, right? Go to This Week, go to Modules, find Today. By the way, if you're in second period, obviously yours would say Tuesday, January 19th, instead of Wednesday. So in class, we reviewed our homework, which was the workbook pages before. So if you have any questions, make sure you send me an email. This link is to introduce a video and introduce E. So let's talk about that really quick. So I'm not going to show the video during this video because that would be a little weird, but I am going to show you a couple of things about the video that are fairly important to know, okay? Okay, so the first thing that you need to know about this video is that E is a number, okay? It's kind of like pi, 3.1415928. I used to know a lot more digits than that, but E is a number, okay, and that value is really close to 2.718. Obviously, it's an irrational number and it goes on forever, but it was invented by Bernoulli, and then Euler actually started, studying it a little bit more, and so the E kind of stuck with him, okay? But here's what it looks like, and here's what you need to know about it. Let me go find it in the video. Here it is. Okay, so E, okay, and by the way, this is what we're going to be talking about on Friday. We're going to be talking about compound interest and compounding it continuously and that sort of stuff, okay? So basically what happens is if you stick your money in a bank, right, the bank will give you interest on your money if you leave it there and don't touch it, okay? So one of the things that it will do, or you can do, I guess, at any bank, depending on what the bank is, okay, you can put in $1, and at the end of the year, they'll give you $1 if you don't spend the money, okay? That doesn't normally happen, which is how the bank sometimes makes money, but that's beside the point. So again, you put in $1 at the end of the year, you have now $2, okay? Then they can add interest halfway through the year. And so if they do that halfway through the year, your $1 6 months later turns into $1.50. Now you have $1.50, right? And they're going to give you interest on that. And so you have $2.25. Then they could do it quarterly, which is 4 times a year. And so you end up getting $2.44. So when you're shopping around for banks, you kind of want to look for a bank that's going to, give you more money if you leave your money there. What happens is the more times that you add interest in, the closer and closer you get, that's what the ... is, to that 2.718, okay? So this particular function, which is really weird to look at, and we're not going to talk about this on Friday, but we are going to talk about something similar to it. Limit is something you're going to do in pre-cal and calc, but basically this is if they would add interest every day, every hour, maybe even every second, as you get closer and closer and closer to adding interest all the time, you get closer and closer and closer to that 2.718 number, okay? These are just a couple of places that E is used in case you didn't know. E is used in statistics. It's used in, I don't know what this is, some sort of science. And then it's also used in like radioactive decay. This, by the way, is why I teach math, okay? Just throwing that out there.
So, while E may not be as famous as pi...
Sorry, I'm trying to get this to... Stop it! Okay, so here's the really fun part. I can't figure out how to go back and delete that. But beside the point, what are we going to do with E, right? So you're going to be graphing it. You're going to be identifying transformations, writing equations, and that sort of thing. Speaking of, let's just get on it, okay? So go find your workbook, okay? You want to find workbook pages 121 and 122, okay? And we're just going to do a couple of these problems together. So again, this is page 121, 122. All right, so on page 121, I'm actually gonna do a couple of these problems with you and help you kind of get started, okay? This is actually easier than what we did the other day, believe it or not. But let's go look at number 1, okay? We're gonna use reference points, horizontal asymptote, and we're gonna graph this function, okay? Keep in mind that your reference points are normally, right, you start with 0, 1, and then you start with 1, and then your base, or E, okay? And from what we did on Friday, or what we did last week, I don't remember what day it was A, and then H, and then A plus K. The other one was H plus 1, and then instead of AB plus K, today it's AE plus K. Keep in mind, E is a number. We already know what the base is going to be, okay? So using these ideas, right, our first reference point, which is H, and then A plus K, this function is not going left or right. So I'm okay to use my H as being a 0, all right? So that's what I'm going to do. I'm going to plug in a 0 right there. So 2 times e to the 0 minus 1. I just have to go figure out what that is. Remember, anything to the 0 power is 1, so this becomes 2 minus 1, which is just 1. So my first reference point is 0, 1. Okay, I'm going to go plot that point, 0, 1. While I'm down here, I may as well go plot my asymptote. Remember, your asymptote is always K. So at -1, I'm going to put a dashed line, okay, because that is my K value. That's my asymptote every time, okay? It's always this, okay? All right, then I'm going to go do the next point, the next reference point. Because my H was 0, I can go plug in the number 1. So I'm going to go do that. 2 times e to the first power minus 1. Here's where I need my handy-dandy calculator, okay? If you are plugging this right into Desmos, that will work fine. If you have a TI-84 or you have another graphing calculator like this, you might want to find out where the E is. Just to show you on this one, it happens to be above, and I'm zoomed way in, sorry about that. It happens to be above the divided by sign, okay? So when I go plug this in, I'm going to do 2. I have to hit my alpha button to get the E. Remember, you want to use the little e, the little Euler E. Don't use the capital E that you see that are green. That's just to stand for a variable, okay? And remember, E is a number. All right, so let's see, e to the first power, and then I'm going to do minus 1, so 4.4-ish, okay? So when I plugged in a 1, I got 4.4-ish. So I'm going to go plot that point. 1. Let's see, 4.4 would be about 4.5. Okay, so there's my 2 reference points. I'm just going to make a little swoopy thing. Remember, don't go past your asymptote. Okay, let's go do number 2. Again, I'm going to use those reference points. So H and then H plus 1. Okay, and if I look, remember that X plus 3 gives me my H value. And so this particular function should have gone to the left 3 places. Remember, it's always opposite, right? What you see up there. So I'm going to use a -3. That's my first reference point. -3 something. Let's go plug it in and see what we get. Okay. So let's see. I'm going to do 1/2 times E. When I put in a -3 plus 3, I get 0. It's kind of a funky looking 0. Sorry about that. Remember, anything to the 0 power is 1. And so I have 1/2 times 1 minus 2, so that's -1.5. Okay, so let's see. 1, 2, go back -3, go down 1.5. May as well go put my asymptote in while I'm here at -2. Okay, my next reference point is going to be H plus 1. And so when I add 1 to -3, I get -2. So that's going to be my next point. And I'm just going to go plug it in. So I'm going to have 1/2 E. Let's see, -2 plus 1 is to the first power. All right, let's go plug that in. Let's see, 0.5 E minus 2, -0.64, so just a little past -1/2. Okay, So let's see, -2 and a little past -1/2. I mean, you're eyeballing it on the graph. Don't go past the asymptote. Put a little shroopy thing. Done. Okay? Numero tres. All right, when you go to when you go to write equations, okay, your equation is going to be a times e to the x minus h, and then plus k. Remember, you have to solve for a, you have to solve for h, and you have to solve for k. Okay? So let's go do that. Our reference points are going to be h, a plus k, h plus 1, and then a e plus k. So remember, I'm just kind of setting myself up so that we can be successful. Okay? So my h value for my first one is -2, and then -1/2. My next one is -1, and then 5/2e minus 3. And my asymptote is at y equals -3, so I know my k value is -3. All right, here we go. H is -2. A plus k is -1/2. K is -3, so I know a minus 3 is -1/2. I'm going to add 3. A is 2.5. I'm going to go check my answer over here. -2. Score. Check my answer. What? Hang on. A is 2.5. 2.5. E minus 3. Does that equal? It sure does. So this is another way to check your answer. That's why I feel like these are a little bit easier. Is 2.5 e minus 3 the same thing as 5/2 e minus 3? Yeah. So you're done. Okay, remember, you only have to find for these A, H, and K. Okay, all right, so when we go to write our answer, we get A. You can write 2.5, 2.5, or 5/2, doesn't matter, times e to the x minus h, so it'll be plus 2, and then plus k, and since it's a -3, minus 3. This one is going to be the exact same way, different numbers. All right, last little detail is how to help you get through the back side. I will tell you for number 5, you definitely want to use Desmos. So go type this equation into Desmos, okay? What you're going to do for this equation after you read the problem, obviously, because you're starting at 100%, you're going to look for 29%. So just take the little mouse and go along the little swoopy. You're going to end up with a swoop that looks like this. You're going to take your mouse, drag it along until you find 29. Write that number down. Then you're going to drag the mouse along the little swoopy until you get to 16. Okay, write that number down. And then you can subtract to see how far apart those years were. For number 6, same thing. You're going to use Desmos. After you read the problem, you'll notice that it says that P of 0 is the initial power supply, and then it says initial power supply is 62, so I just plugged that in. So go plug that in. What you're going to do when you use Desmos is you're going to also type in y equals 10 and find out where they intersect, okay? When you're finished with that, you're going to use this equation to find the growth rate or decay rate, okay? Number 7, the answer is yes, they absolutely do intersect. Your job is to kind of figure out how, okay? I will tell you and give you a hint, hint, wink, wink, right? It has something to do with those reference points, okay? And then number 8 is relatively easy. You just need to figure out which graph it is. Okay, make sure you shoot me a message or an email if you have any questions. Toodaloo!